Good evening, everybody, and thank you for weathering the storm. Just remember that winter here is like 60 degrees. Anyway, hardy crowd. Well, we've had now a few lectures, and the first couple of lectures sort of set the stage about what artificial intelligence and machine learning was all about. The third lecture in particular talked about the complexities of getting people that deal with big data and those that actually need the big data working together. And last week, I think we saw a practitioner of big data and artificial intelligence and machine learning. So we've seen all that as we come along today, and we'll have a lecture about some of the morality issues and some of the ethics that surround some, of course, unintended consequences, but some are intended consequences, and we'll hear a little bit about that. This is, of course, free because some people in the community really help us out with the funding. The individual that actually goes out and helps get the funding is Bob Logan. Many of you may know him. He's the Assistant Dean for the College of Science for Relations with the Community, and he wants to talk to you about something.
Thank you, Joaquin. I'm not going to ask for money, okay? But here's what we're going to do. We're going to do three things tonight. We're going to recognize the sponsors and the partners that Joaquin normally does each evening. Then I'm going to announce a program where you can get engaged in the college in a higher way than you normally are. If you've only been coming to the lecture series, we're going to give you an opportunity to engage, and so we can communicate with you with other great things that we do for the college. And then the third and the final thing is we're going to give out a $6,000 package. So hopefully that got your attention. But let's recognize the partners, because as Joaquin has said in the past, this is a huge undertaking, putting together the lecture series. And there are a number of partners that you see on the board here. And no offense to Jim Click or Jack Furrier or Sam Levitz, but there's no marketing value for them to get engaged with this. They do this because it's good for the community. They do this because they know the content we deliver, and we deliver it free of charge because it's a great service that we've been doing for 13 years. So let's go through who the partners are. We have three title sponsors, and the first two were Roche, formerly Ventana Medical Systems, and Tucson Electric Power. They've been with us for the entire 13 years of the series. I'm going to ask you to hold your applause till the end. And then we just, this year, got a great campus partner, the Office of Research, Discovery, and Innovation. They have a number of their faculty members who are speaking this year during the series, so they wanted to step up and be a partner. So thank you, Kimberly Espy. So a round of applause for the title sponsors. And I'll go through this long list real quickly, just make a couple of comments about a few of them. Accelerate Diagnostics, you may not know about. They're a startup company founded by some members from Ventana Medical Systems, of all places. Arizona Daily Star, they give a great amount of exposure in the newspaper with banner ads, and then at the end of the lecture series, they turn around and give us $7,500 for the Galileo Circle to fund scholarships and faculty fellowships. So they're a great partner. Canyon Ranch, we're going to skip that one and come back in a second. Cox Communications and Lisa Lavallo, you'll see some commercials and some streaming on Cox. Galileo Circle, all of our friends and donors that support about $250,000 of support each year for students and faculty members. Thank you, Galileo Circle members. Godat Design, Ken Godat, the graphics that you see here and the PowerPoint slides that you see with the speakers are largely designed by Ken. And the animations that are put in place, he does an amazing job. So thank you, Ken. Mike Kasser, Holualoa Companies, again, been with us for the entire 13 years. Marshall Foundation, Jane McCullum, who is right there. Wave your hand, Jane. Thank you very much. You may not know what the Marshall Foundation is, but do you know where Gentle Benz is? Do you know where Frog and Firkin is? All right, that all Main Gate Square is managed, that real estate is managed by Marshall Foundation. So if you want a lecture series next year, you got to go to Gentle Benz after the talk tonight. Let's see here. Quan Nguyen and Tarbit Patent Law Firm. Here's a guy that's on our College of Science Board of Advisors. And he does a lot of the patent work for our commercialization and our startup ventures within the college. Raytheon Missile Systems, again, been with us for the entire 13 years. Research Corporation, new CEO, Dan Linzer, had no idea what this is all about. I met with him and I gave him a picture of the audience. He says, okay, I'm in. I can tell that it has an impact. And then finally, David Allen and Tech Launch Arizona. They make this happen, so please give them a round of applause. Okay, as an external person, you know, Joaquin says as a land-grant institution, we need to make sure that we're delivering this content as a service to you, the taxpayers. And we've done this for free. We're never going to charge ticket prices. We want it to be free. But one of the things we want to do is give you an opportunity to engage. As an external person, you know, we don't know who you are. Outside of the Galileo Circle and maybe some people on our email list, you may come to the talk, enjoy Jane tonight and Luis last week, and you go back home and we don't know how to communicate back to you. So we're going to give you an opportunity to do that. So if you know how to text message, I'm going to give you another opportunity too. If you text message the phone number 22333, right there, and the message is Arizona 2018. You're going to get a response back in a couple of seconds, and if you put your name and your email in there, we will have you as a member of our Science Insider. Now, what does that mean exactly? We're putting this program together as we speak, but as an example, last year we had the launch of OSIRIS-REx and Dante Loretta. We took 150 people down to Florida, and we watched the launch of that rocket, and it was a transformational experience. And you folks could have gone. It wasn't a donor trip. If you could afford to go on the Florida trip, you could be there on Cape Canaveral and the backstage tour of the Kennedy Space Center. We're talking about maybe providing the slides from the lectures that you see in a PDF to all of you. So if you enjoy the lectures, we can provide them through the Science Insiders program. Now, if you don't know how to text, you were given this little ticket when you came in. If you'd like to put your name, your email, and your phone number on this ticket, and over on the left, Frankie Kolb, wave your hand, there you go. After the talk, she'll be on that patio, and just hand her the ticket and we'll manually input the data. Now, I promise you two things. When we talked about doing this, we thought what better time to do it is during Artificial Intelligence Lecture Series. So number one, we will be great stewards of your data. We're concerned about privacy. You're going to maybe hear about some of that tonight with Jane. We're not going to give this information to anybody else. It's for us and the College of Science. So you can be assured that your data will be safe with us. I know some of you are sensitive to that. Now, when you go on late night TV and you see the infomercials, the Ronco Vegematic, what's the phrase that they always say at the end? But wait, there's more, correct. So here's a way that we're going to entice you. Canyon Ranch is a new partner to the college. Just happened a couple of weeks ago. And Canyon Ranch is founded by Mel Zuckerman. You may recognize the College of Public Health is the Mel and Enid Zuckerman College of Public Health. Big fans of the university. They have been sold and they are looking to change their delivery system. It's one of the best spas in the entire world, but they're trying to deliver content. So as an example, next September, we're going to have a science week at Canyon Ranch. 6 or 7 consecutive nights, we'll have faculty like Steve Kuberoff or Chris Empey giving a talk to Canyon Ranch clients. We're going to be giving stargazing exercises at Canyon Ranch. In return, they have given us a $6,000 package to Canyon Ranch. So if you don't care about the lectures, but you want to have a good massage and hear a good science talk at Canyon Ranch, sign up. So same thing, 22333, Arizona 2018. Your name and your email will already have your phone number, and you will be one of our science family members. So I hope you take advantage of it. We want to communicate to you on a more regular basis, give you opportunities to engage at a higher level. So ladies and gentlemen, thank you very much.
And I hope it was clear that there'll be a raffle. Not everybody's going for free, but there will be a raffle, and one of you will be lucky to go there. Okay, Jane Bambauer, we're very lucky tonight. She's a professor of law here at the University of Arizona. She holds a Bachelor of Science in Mathematics from Yale College and a JD from Yale Law School. And I asked her why she went from math to law, and she said it's the same thing. It's logic, for sure. Jane's research assesses the social costs and benefits of big data and questions the wisdom of many well-intentioned privacy laws. Her own data-driven research explores biased judgment, higher education, and legal careers. Her articles have appeared in the Stanford Law Review, the Michigan Law Review, the California Law Review, and the Journal of Empirical Legal Studies. She's also written for Huffington Post and the Washington Post. And please welcome Jane Bambauer.
Thank you so much, Joaquin. Thank you. Thanks for coming out. Lawrence Lessig, the famous law professor at Harvard, once said that code is law. What he meant by this is that much like with the law, computer code winds up structuring and ordering human behavior so much, so completely, that it blends into the scenery. So machine learning and AI is just a special case of what Lessig was talking about. We interact with machine learning algorithms almost every time we do anything on the internet. So when I do a Google image search for the term CEO, Google's search algorithm will return an array of images that might look something like this. You've probably noticed something about the demographics here. A lot of men, a lot of men. But then again, only about 5% of Fortune 500 companies' CEOs today are women, so this might be representative. But is it possible that Google's algorithms are doing more than just reflecting the world? Might they also be shaping it? If you think that sounds a little far-fetched, consider a different Google algorithm, the one that decides which advertisement to place on Google's many websites. Well, some researchers at Carnegie Mellon University wanted to understand a little more about how this algorithm works. So they created a whole bunch of fake profiles, and they worked with them in pairs. And every pair did the exact same search and web surfing behavior. The only difference was that one was marked male and the other was marked female. Well, the female profile was shown advertisements for high-paying jobs a lot less often, in fact, just a third as often as the same profile that happened to be marked male. Same behavior, different advertisements. So that suggests that Google's algorithms are also influencing the pipeline that goes to the corner office. So what's going on here? It's possible that Google sells advertising and allows its advertisers to explicitly reference gender when they're giving their requests for what type of viewers to see. I doubt that that's what's happening. I don't think Google would take the reputational or the legal risk of something like that. The more likely explanation, and it's one that the company sort of hinted at in response to this study, is that real Google users who are women click on these types of advertisements less often than similar Google users who are male. And the reason that matters is that the algorithm is optimizing for click-through rate. That is, it's trying to get people to click as often as possible on the advertisements that are shown. So that's a perfectly rational explanation for the gender gap that we see. Does that mean that the algorithm is fair? Well, this, in a nutshell, is what we're going to talk about tonight. What do we do when an algorithm might be treating people unfairly, and how would we even know? The topic is ripe. Algorithms are assessing us on a whole bunch of different attributes almost all the time. We've been used to, for a while, having something like a credit score assess how creditworthy we are. Well, now there's a second generation of credit scores. They use all sorts of unconventional data, like your Facebook profile. We're also being assessed on new things, like how likely we are to follow our doctor's advice, or how good we're going to be at a job that we don't have yet, or how long we'll stay at that job. China, the Chinese government, is working with a whole bunch of private companies, including Sesame Bank, one of the largest banks, to create a whole bunch of what it calls social credit scores that would measure all sorts of different personality attributes about people, like how generally reliable they are, or how loyal they will be to the Chinese government. What can go wrong with that, right? They're also sizing us up to get a sense of what type of content we want to see. Facebook's newsfeed algorithm has figured out that I like to see a lot of cats. And Google, of course, tries to predict what it is that you're trying to search for before you're done telling it. So a lot is going on, and this lecture series has asked a bunch of very provocative, forward-looking, big philosophical questions, like, are robots going to inherit the Earth? But tonight I'm going to do something a little bit more pedestrian, or ask a question that's a little more immediate, at least. What do we need to worry about right now? That's the kind of question that lawyers ask, and I'm a lawyer, so it's appropriate. Oh, good. You guys like lolcats. Good. If you were hoping to learn what the law of AI or machine learning is tonight, I have some bad news. There isn't much. We're living in a Wild West right now. That's actually why I like this area so much. To craft the law right, we're going to have to really understand the problems that AI and machine learning might bring, and they're complex. But it's important to structure the law well, because we want to harness a lot of the advantages while also steering the design of AI in directions that are just and equitable. So let's talk about what makes an algorithm fair. Fairness, of course, has a lot of dimensions, so I'm going to focus on 3 tonight. First, is an algorithm biased? I'm going to spend the most time on this because this is the topic that comes up in the media the most. But we'll also look at whether the algorithm is manipulating or even deceiving us in some way. And then at the end, we'll spend a little time, on issues that are often designed and implemented without a lot of forethought that really should be decided by a human. So let's start with bias. In order to have a fruitful discussion, I'm actually going to go over some of the things that Stefan described in the very first lecture, because it will help us be more precise in the definition of bias. So Stefan reminded us that at the core of artificial intelligence is machine learning, and at the core of machine learning are algorithms. And algorithms are just recipes. They're just rules that a human or a computer could implement so that they get some answer to a query. Well, it used to be that the humans had to decide what those rules were, but machine learning, the big innovation here was that instead we could give the computer a whole bunch of input and output pairs and have the computer figure out what the rules are. And it would do a good enough job of estimating so that then when we gave it a new input, it would figure out what a good guess for an output would be. So for example, a dog-cat classifier would be given a whole bunch of correctly labeled pictures, and then it would figure out what the rules are so that when you give it a new picture, it could pick whether it's a dog or a cat. Now, at any given time, the algorithm is going to be working with a specific set of rules, and I'm going to refer to this as the model. So after seeing a library of pictures, maybe the computer has figured out that, okay, if this thing has pointy ears, it's more likely to be a cat. But if it has a long snout, then it's actually probably not a cat. It's maybe more likely to be a dog. And the actual model, of course, is one long equation that weights all of the factors and then pops out some estimate of how likely it is to be a cat or a dog. But this is enough to give you a sense of how it's working so we can be a little more precise with what types of bias would bother us. So one version of bias is that we would want the algorithm to provide answers that perfectly reflect the general population, or maybe that have an equal probability of any particular answer. In that case, my search for the Fortune 500 CEO should produce 50% female images. This is not usually what we care deeply about. We understand that in most contexts, equality is not the same as equity, as fairness of the process. So this is not necessary. I'm not going to start with this as the basis for figuring out whether there's bias. In fact, in the law of employment discrimination, the Supreme Court has gone as far as to say that any intentional intervention in order to get outcomes that are racially or gender balanced, that intentional process may itself violate the law. So in a case called Ricci versus DeStefano, the New Haven Firefighters Department had designed a test that it was going to use to make promotion decisions. But then after they administered the test, they realized that white and Hispanic firefighters got significantly higher scores than African-American firefighters. And there was a big debate about whether the test was designed well, and so they decided to throw it out and use a different mechanism to make promotion decisions. Well, the Supreme Court, in a 5-4 very contested decision that was split on ideological lines, decided that the intentional decision to abandon the test was itself discriminatory and violated Title VII, the federal employment discrimination law. So that's a controversial version. That's a controversial case. But even so, most of the time what we really want to do is we want outcomes to reflect the appropriate pool. And we may debate what the appropriate pool is, like what it means to be a well-qualified candidate for promotion, for example. But we're looking for representation of something other than just the general US or world population. So Google's search algorithm might fit this definition if we're using Fortune 500 CEOs, right? Because it returned 5% female. By the way, a lot of algorithms don't meet this. This is just the bare minimum, and a lot of algorithms won't meet it. Mihai, in the second lecture, told you a little about this algorithm that was guessing the gender of people in photographs based on the context that they were in. And the algorithm had overlearned to associate a kitchen with being female. Now, once you understand how machine learning works, it's easy to understand how this can happen. Because if you start with a library of photographs, and if you take all the kitchen photographs, and 60% of them are female and 40% are male, what would you do if the next photograph had a lot of factors, but it was kind of a mess? All you knew for sure was that there was a kitchen in it. What would you guess was the gender? Female, right. And that's what you would do every time that you were in that situation, right? Where the other factors were ambiguous, all you knew for sure was a kitchen. So that's how something that might start as a 60% bias in the training data can turn into 80%, 90%, much more bias once the algorithm is actually going. Another kind of horrifying example of a program that wound up magnifying some attributes that were in the training data is Microsoft's AI chatbot called Tay. So the way Tay worked, you may have heard about it because it was that horrible. Tay had an initial tweet that was made public to the world. Can I just say that I'm stoked to meet you, humans are super cool. And then anyone could tweet back at Tay, and Tay would learn from the messages that were tweeted at it, and would try to figure out what people wanted to talk about, and would try to tweet again, sort of mimicking the human style. Well, there was a concerted effort among pranksters and internet trolls to turn Tay racist and bigoted. And so even though Tay got a sort of a wide range of responses, this concerted effort was such a strong signal in an otherwise noisy field of information that in less than a day, Tay was unrelentingly, irredeemably awful. Yeah, this was just the one I was willing to show you, by the way. So as a very first step, we want to make sure that the outcomes are representative. But that might not be enough. We might also worry that even if the results are overall representative, there may be error that is, there may be error and there may be consequences to that error that is not distributed fairly, where some subgroup, maybe a vulnerable subgroup, is suffering from more than its fair share of the error. This can happen a few different ways. One way is that the model itself might be using some inappropriate factor like gender or race in it. And when that happens, that's usually going to be obnoxious because that factor is probably standing in for some other explanatory factors that should be in the data but aren't. And so instead, the model is relying too heavily on these demographics. It can also happen even without explicit reference to those demographics if the computer has learned to use a close substitute like complexion or hair length or zip code. At least in some cities, zip code is highly correlated to race. So an example of this that is a historical example that predates big data is the redlining practices that banks used to do. So banks used to routinely deny or offer home loans on much worse terms if the home that was being purchased was in an area, in a neighborhood that was predominantly minority. So that's an example of use of an inappropriate factor. But the harder cases, and the more prevalent cases, are algorithms that don't use any sensitive factors or any close substitutes, but still have results that have some sort of disparate impact on some group that we would want to protect. This too can happen in a few different ways. First of all, the data that trained the algorithm might itself be flawed. So to give an example, the facial recognition software that a lot of police departments started using was trained on an insufficient library of African American faces. So then when it was used in the real world, the false match rate for African American faces was much worse than for white faces. Even if the model itself, though, seems to be producing appropriate results, the way that we use those results may wind up putting some pressure on one subgroup or another. So to give you an example of this, I want to do actually a deeper dive with one of the most controversial algorithms that's used in the criminal justice system. So I'm going to be talking about the COMPAS scores. These are scores that attempt to predict recidivism. So that is, if somebody's been arrested, they predict the chance that the person, if released, will go commit another crime. And these scores are used to make bail decisions and also sentencing decisions and parole decisions, too, in some jurisdictions. And it's caught a lot of controversy and criticism because it looks like it's producing some biased results. So let me tell you a little bit about how the algorithm works. It uses data that is collected from criminal records and from a questionnaire that everyone who's arrested has to fill out. And it uses 137 different variables. That sounds like a lot. It's not that much. This is more of a little data system than a big data system. But the variables that it uses are things like the age of the person, the number of convictions and arrests that the person has had, the age that they were when they first committed their first crime, how recently the most recent crime was, that sort of thing. Importantly, it does not use race, and it does not use zip code, or at least in most jurisdictions it doesn't use zip code because that too correlates too heavily with race. So then the algorithm spits out a number between 1 and 10. 1 is a low score, low risk of committing a felony within 2 years, and 10 is a high score, highly likely to commit a felony. Scores that are in the medium and the high range are generally treated as risky. So these are the folks that will get a longer sentence or might be denied bail pre-trial and would be held in jail before they were convicted, that sort of thing. Okay, so a team of journalists wanted to know how these scores might affect different subgroups. So they did something clever. They took thousands of people who were arrested at one point and were scored, but then they were released. They were never charged with anything. So they were released, and we can see what they wound up doing. We could see whether in 2 years they wound up being arrested for a felony or not. We could check the accuracy of the scores. So the journalists looked at just the people who did not commit another crime within 2 years. And they wanted to know, okay, what was the chance that this person would have had a medium or a high score, meaning that they would have spent additional time in jail or prison? Well, for white arrestees, that false positive rate, right, so these are people who didn't commit a crime but would have been treated as if they will. The false positive rate for white arrestees was 23.5%, but for black arrestees, it was much higher, almost 45%. So this looks like pretty compelling evidence that something is going wrong with the scoring system. But I actually think that the scores are not where the problem is. The problem is actually from how humans are interpreting and using the scores. So let me tell you why I think that. For any given score, the chance that a person will be arrested within 2 years for a felony is the same whether the person is black or white. So score for score, the chance of a felony arrest within 2 years is roughly the same. How can this be true, and yet how could the results that we just saw be consistent with this line graph? Well, the difference has to do with the distribution of the scores that each group is getting. Black defendants tend to have scores that are pretty flatly distributed, whereas white defendants, most of them get low scores, and only some of them get these higher, mid-range and higher scores. And remember, the algorithm isn't using race, so it's the factors like the criminal arrest history and whatnot that's producing this difference in the distribution. But the reason this matters so much is that it's the medium scores that produce the false positive error, because these are the folks who actually only have a roughly 50% chance of going on to commit a crime, but they're being treated like the 9s and 10s. They're being treated as a significant risk. So this is good to know in advance, because once you see this broken down, you'll understand, if you were a judge making these decisions, that if you treat someone with a medium score the same as you treat the high scorers, it means that that decision is going to have a disparate impact on the black community, and that communities of color are already sort of laboring under an over-incarceration problem. So that in itself might tilt toward giving us somewhat different treatment to the medium scoring people. So as Stefan put it in the very first week so nicely, I thought, the problem here is not with the algorithm. The algorithm did exactly what we told it to do. The issue is with how we used the algorithm's output and our lack of understanding. By the way, there's one other way in which the human decisions influence this kind of the cycle of over-incarceration. I mentioned that these scores are predicting the chance of being arrested within 2 years. Well, we know that there are many crimes, especially nonviolent crimes, that are enforced very differently depending on where you live. In areas with a heavy police presence, highly patrolled areas, enforcement of some crimes is much greater than in other less patrolled areas. So that means that we're having the Compass scores predict something that isn't really quite the same as the risk that somebody is placing on society, right? Ideally, we would want to know whether the person goes on to commit a crime, not whether they are arrested for a crime. But the trouble is, we of course don't have good data on people who commit a crime and are not arrested. So this might be the best we can do, but it's another way that that humans are influencing and causing, sort of exacerbating the racial bias. All right, so you've seen now that the problems with bias are pretty complex and nuanced. What should the law do to respond to algorithmic bias? Well, one thing, one idea that's getting some traction right now is that governments might want to incentivize or even require companies that are producing these heavily used algorithms to do some audits, meaning they should take some synthetic data, fake data that has roughly the same properties as real people, and run it through the algorithm to see if the current model produces results that look fishy or that have problems, some of the problems like the ones that we've discussed. So that seems promising to me. It's also tempting to think that we should be designing anti-discrimination laws to prohibit the use of certain types of algorithms to make certain decisions. There, I think we need to have some caution for a couple of reasons. First of all, it's not always clear that if there's a disparate impact, that there's an actual problem if the algorithm is also doing a very good job of predicting an appropriate outcome measure. So, so the context in which those types of laws would be appropriate might be limited. Also, as you've seen, the Supreme Court is going to be pretty skeptical and hostile to government interventions that are designed with the express purpose of achieving racial or gender balancing, even when those interventions are done in order to help a historically disadvantaged group. So that's one reason you aren't seeing a lot of rush to regulate in this area. All right, let's talk about how algorithms manipulate the information that we get. So AI is getting very good at creating fake content. Companies like Amazon and Yelp that rely on user reviews are having a really difficult time screening out the reviews that are created by machines. So to give you an example, here are 2 reviews, one of which was written by AI. Can you tell which one is the fake one? I'll give you a minute. Is it the chicken or the scallops? The fake one is the chicken. And if you got that wrong, I did too. So you're in my company. Not necessarily good company, but you're in my company. AI is also getting really good at making fake news stories, and in the future, it will probably be good enough to make fake but very convincing video and audio as well. To demonstrate, I'm going to actually show a video of what can be done today. It's already pretty good.
And can create the most realistic computer-generated characters. Think of a young Princess Leia's appearance in last year's Rogue One. But what if smartphone users had the same power at their fingertips? Today, researchers are developing software that harnesses artificial intelligence to generate lifelike but fake footage. Startups like LA's Pinscreen only need one selfie to start modeling the facial features of a video avatar that can make you look like a video game character or like a real-life person. Pinscreen believes the technology can make communication more engaging when your real self isn't available. The company has gotten so good that what you're watching now isn't even real. I'm merely a computer-generated realization of myself created from a photograph. To prove it, I'll say things that are patently false things that the real David person would never say. The hot dog is a sandwich, and the Yankees are a gift to baseball. And therein also lies the risk of such a breakthrough. At a time when fake news has dominated discourse, AI-generated video may only make it harder to know what's true and what isn't.
All right, there's a happy thought. Law is going to have a really hard time chasing this problem down, too, because a lot of the people who are interested in using malicious code of this sort are not in the US. They may be protected by governments that have no interest in extraditing or helping an investigation. Indirect means, companies like Facebook are already very, very interested in trying to solve this problem, so there's not a lot more we can do to incentivize them. But AI, although it's the source of our problems, may also be our savior. So AI has the chance of, it has the power to look for sort of language quirks or mismatching text that humans might miss. By the way, in the first ever fake news challenge, where over 70 computer science teams competed to try to identify fake news, a team from the U of A got 5th place. So a lot of this, yes, a lot of great work's happening here. But even aside from attempts to deceive people, algorithms can provide information that is in some way manipulative or problematic. So I started with the example of Google's advertisements that may reinforce stereotypes. Even the perception of bias can cause problems. So this, the most recent presidential election, some fans of Donald Trump noticed that when they typed Hillary Clinton is, Google autofilled only nice things, even though they knew that people were constantly searching for Hillary Clinton is a criminal or a liar, and the other search companies had those results at the top of their options. So they concluded that Google must be using its search engine dominance to help the Hillary Clinton campaign. They were wrong. Google had already instituted a policy that anytime someone started Googling a proper name, Google would not autofill negative traits. So Donald Trump got the benefit of this rule too. So even avoiding talking about Donald Trump's sex scandals or his sexual assaults. My favorite example, though, is Bernie Madoff. So Google would sooner fill in Bernie Madoff cricket than criminal. But these perceptions matter, right? So if a sizable chunk of people think that the world's most important filter of information is ideologically biased, they will not just distrust Google, they'll distrust people, and they'll distrust democratic institutions too. So these perceptions do matter quite a bit. AI is also being used to greater and greater extents to study us. I know Luis talked about how commonplace this is with apps and websites, including Duolingo, to do sort of what are called A/B tests, where half the people see some sort of new feature to see whether that feature works well or not. Facebook a few years ago, though, came under some scrutiny because they were doing more sort of general social science research. In one of the studies, they enrolled people without telling them that they were part of an experiment into an experiment where half the people saw news feed posts that were a little happier than normal, and the other half saw news feed posts that were a little more negative than usual. And Facebook wanted to know if it would affect the posts of the user himself. And sure enough, there was a small but statistically significant effect on the mood of the Facebook user. Or at least there was an effect on the Facebook user, what the Facebook user said that they were feeling. Another experiment found that Facebook's social get out the vote message, where they showed not only a little, I voted sign, but also showed pictures of people who said that they had voted. Those who saw the social message were slightly more likely to vote than those who didn't see it. So that means that, at least at the margins, Facebook's newsfeed algorithm has incredible power and a lot of influence. There's also just the larger problem, or at least a potential problem, of hyper-customized content. So if we are not exposed to content that tends to challenge our pre-existing beliefs and our tastes, then we may not be as willing to change them as we were in previous generations. Eli Pariser and a number of other people have wondered whether this phenomenon of the filter bubble is causing some of the polarization in culture and politics that we're seeing today. Now, I think the jury's still out on that theory, because there's other research finding that actually we're exposed to more viewpoints than ever before today. But the trouble is, when we go to content that kind of disagrees with our worldview, we go with this irrebuttable skepticism. So it may be kind of closed-mindedness more than lack of access to content that seems to be the problem. Like I said, we're just still not sure what's happening. But if you've been following all of these kind of tech stories, you might be wondering what the law is doing to help. So there are a few reasons that development has been sluggish in this area. It's not just lobbying by Google and Facebook, although they do a lot of lobbying. But also, these companies are at core information services. And the Supreme Court, under Chief Justice Roberts, takes a distinctly libertarian approach to the First Amendment. So anything that is information, even dry information like personal data and computer code, is probably protected by the First Amendment, and regulation would require a sort of special justification and careful tailoring of the law. In a recent case, Sorrell versus IMS, the court struck down a law that Vermont had passed, and the law was attempting to restrict pharmaceutical companies from collecting prescription data that they were then using to tailor their advertising to doctors. And the court found that that type of law was a restriction of speech because it restricted information. So, so this is so if we regulate in this area, legislators will probably have to be prepared for a First Amendment challenge. Okay, finally, I'm going to end with a few other kind of factors that matter quite a bit that usually are not thought about concretely. So first of all, one problem with algorithmic decision making is that it may be that we actually don't want to differentiate between people, even though we're doing it. To give an example, before the Affordable Care Act was passed, health insurance companies had a lot of incentive to try to figure out who was going to be sick in the future and who wasn't, pre-existing conditions being one of the biggest factors that could be used. And that way, the health insurance companies could pool the healthy people and offer them lower rates, and then the sicker population would either be denied coverage altogether or would be offered much worse terms. One major policy decision that the ACA incorporated was that we're not going to do this anymore. The health insurance companies need to pool everyone into a single pool, and if that means the healthy population is cross-subsidizing the less healthy population, so be it. So that's, that's certainly a defensible health policy outcome. But what it means is that there's no incentive anymore for health insurance companies to try to optimize and work with machine learning to try to figure out who's going to be healthy in the future and who isn't. Okay, another issue is whether the algorithm is accurate enough. Now, as Stefan said in the very first lecture, algorithms don't have to be perfect in order to be very useful. But Mihai reminded us that there can be flaws once the algorithm is working with real-world messy data that are so devastating that the entire project should be abandoned, at least if the consequences are serious enough. So, confusing a panda for a gibbon doesn't matter much, but once we're talking about driverless cars, the stakes are a little higher. Even if the algorithm has low error compared to what we're used to working with, there could still be more cost to society if we overuse the technology. So, for example, red light cameras that are kind of a sort of simple version of an algorithm, they can automatically figure out which cars are driving through the red lights, scan the license plates, and generate a ticket and send it, right? So the red light cameras might be more accurate than a traffic cop who's just using their eyeballs rather than sensors. But even if they are, we can put those red light cameras on every intersection and have them running at all times. And so as a result, they may issue tons more citations than the police ever could. And most of those citations would be valid, but they could nevertheless issue, in absolute terms, more invalid citations as well. So I've called this concept hassle in some of my Fourth Amendment work. It can be avoided. We just need to decide what the threshold for absolute error is and then make sure that we don't use the technology so much that we're breaking that threshold. Okay, so, oh, by the way, that's right, Tucson banned red light cameras. So there goes my, cleverest example for hassle. Yeah, oh, okay, okay. All right. I know how you all voted, okay. Another problem with machine learning is that the rules of the algorithm, the model, gets very complex very quickly and is often just a set of correlations without a causal story or theory. This would be a problem in at least some contexts if we need people who are going to suffer some sort of bad consequence to be treated with dignity or with due process. For example, taking a criminal justice example again, if you're arrested or if you're searched, you're owed an explanation of why the police thought that you were suspicious. What gave them probable cause to think that you were arrest-worthy. A series of correlations probably doesn't fit our current understanding of the explanation that defendants are owed. Okay, algorithms also might wind up having to make moral decisions that we've never had to solve before. Tackle problems we've never had to actually solve. So MIT is doing a cool experiment right now. You can go online and do this yourself. It's pretty fun. I encourage you. It's called the Moral Machine, and it's to prepare for a day when autonomous cars might have to decide what to do in an accident situation. So you can decide, okay, should the autonomous car run over the pedestrians, or should it swerve and kill everybody in the car? And so you can run through a whole bunch of scenarios, and then you get to see how your answers compared to other people. So I care a lot about humans, which I am proud of. But I also care an inordinate amount for the elderly, which as a mother of a 5-month-old baby, I don't think is a very good sign. But I don't know. I guess I didn't notice the strollers. Anyway, but these scenarios, right now, these are still just hypothetical problems. Like the sensors are not nearly good enough to require us to solve these quite yet. But down the road, it might be. And so that means that car manufacturers are going to have to program an answer to these questions. And it's going to be unsettling, because not everyone's going to agree on what should be done. Finally, the use of algorithms, even if they're doing exactly what we want them to do, we're really happy with them, they may just require so much data surveillance that it causes people to be nervous today about data that's collected about them for how it's going to be used against them tomorrow. And so that surveillance might lead to reserve and distrust that may not be worth it, depending on what we're doing with the data. So that's a lot of problems I've run through in a short amount of time. How do we manage AI so that we get what we want out of them without getting too many of the problems along the way? Well, I've spent a lot of time telling you about the bad part of machine learning. We've spent some time with the scary version of AI. I want to spend at least a couple minutes scaring you with how bad organic intelligence can be. Because humans use algorithms too. Anytime we're deciding or differentiating between people or things, we only have 2 ways of doing it. We can use rules, which is another way of saying an algorithm, or we can use randomness. And humans have some problems with both, human systems. For example, our rules might be bad. This graph is plotting the chance that a judge will grant a parole decision over time, over the time of a day. And the dotted lines are the lunch break and the afternoon break. So that's not random, that's a rule. That means that part of the algorithm that judges are using involves the question, am I hungry? And if the answer is yes, the person is much less likely to get parole. So that's not a good rule. That factor has no business being in the algorithm. People are also random. So now what you're looking at is, these are a bunch of judges, federal judges, sitting in the county of San Francisco. And this is the chance that they will grant an asylum request. And what's important here is that since they're sitting in the same county, they're seeing the same types of cases. They are seeing the same types of populations of immigrants. And yet, one judge grants asylum requests 97% of the time, and another judge grants it 9% of the time. So that means as an asylum seeker, the single biggest factor in terms of whether you will be granted asylum or not is who you are randomly assigned to hear your case, right? Which judge has your case. Yeah, that's scary. That's wrong. So, computers have some advantages. They don't have ulterior motives. They can see patterns we can't. They have stamina. And they can have even-handed application. Yet none of those things are going to guarantee that the process as a whole is fair. Humans have some advantages, too. We can set priorities. That's probably the most important advantage. So as we design law, we're going to want to harness the advantages of machines and humans at the same time. And crafting law is going to require some sensitivity to the context. So I want to end with some ideas of what can help us design laws well. New York City right now is convening a task force to figure out how algorithmic decision-making can be done in a fair way. And I think it's good that they're doing this kind of just initial information gathering and educating. And the U of A is a hub of research that I think is also going to be a critical component of designing laws well. So to give you a sense of what's going on here, a team of researchers at the School of Information are working right now on a publication about unintended discrimination that algorithms can cause and how to fix it. And one of the suggestions, by the way, is the sort of audit procedure like the one I described. Laura Brandemart in the economics department is looking at how humans respond when they know that they're being surveilled. So she does a lot of really cool research. My own husband, this is a bit self-serving of me, but my own husband, who also teaches in the law school, is doing some neat survey research right now on what people prefer if they could choose between being assigned to a human or an algorithm for some sort of decision. What do they want? And as you see, we're sort of split, but the bigger camp by far would choose a human no matter what the context is and no matter what type of decision is being made. So this is just a small sample of a lot of great research going on here, and it can help us understand the problems that we're going to be facing now and in the future a lot better. But ultimately, all of the problems that I've described tonight are interconnected. So if we start trying to minimize one of the problems, it will affect the others. So for example, if we want to make an algorithm as accurate as possible, that effort might increase the bias, or it might require a lot of extensive data gathering and to violate privacy. Or it might mean that the algorithm is less intelligible, less understandable, and therefore less accountable. So the problems we have with algorithms are not really with the algorithms. It's with setting priorities between these competing policy goals. And those are decisions that are going to be critically important for the future, and that can't be left. Yeah, that's my baby. And these are decisions that can't be left to computer scientists and programmers alone. As wise and as big-hearted as you are, I know you're out there. They're decisions that are going to affect human lives in very crucial and critical ways, and so we need to be making these decisions collectively. Thank you very much.